Right. So today we're going to see a few examples of the product rule and differentiation. Okay, so we're seeing the product rule in action today. Now let's say I have a function like so, a very basic example, and I need to differentiate this function. Alright, I need to find dy over dx. So this is a very clear example of the product rule. You have two functions and you have their product. So according to the product rule, just state it again here, if I have a u times v, two functions, and I want to differentiate them with respect to say x, so you just keep the first function as it is, you differentiate the second function, and you add to this the second function as it is, and differentiate the first. Okay, the first function as it is, differential of the second function as it is, and the differential of the first. So that's the simple product rule that we're talking about. Now in this case, let's find dy by dx here. We have x times sine x, the first function. Let's take it x. You can take any function as the first function, and the derivative of sine x, which is a cos x, plus the second function as it is, and the derivative of the first function, which is a 1. So you get an x cos x plus sine x as the answer. Okay, suppose we have e to the power x cos x. I want to differentiate the same, the product rule here. Okay, so you take out the first function as it is, you differentiate the second, you get a minus sign, which is the derivative of the cos function, and you add the first function as it is and the derivative of the first, which gives back e to the power x. Okay, this comes out common, and you get this as the answer. Let's take another example. Now let's say we have three functions as products. So we have u times v times say z, and want to find out d by dx. And let's say another function like e to the power x. Okay, e to the x. So the rule for this, this is just an extension of the previous one. You take the first two functions, you differentiate the third. Okay, the first and the last, differentiate the second. The second and the third, this is a v, differentiate the first. Okay, simply. So that's what I'm going to do here. Let's take the first two functions as it is, differentiate the third, which gives it back, plus the first and the last function. Derivative of sine is a cos, plus e to the x and sine x, and the derivative of the first function, which is a 1. So you get an e to the power x common, cos and sine. So that's the answer. So you can take the product rule and extend it for any number of functions in the product and differentiate them. Right? Just take the pair of functions constant, differentiate the one that is left out, and do the same for the other. You will form the number of pairs which will be equal to the number of functions. Like we have 3 here. Okay, 3 sums of 3 terms, and there are 3 functions here. Similarly, in case of 2 functions, we got 2 terms. Okay, so that's the product rule.